Okay, so this is chapter 4 and we're going to be turning on the MPLS. Now we've got LDP here in sort of two clamshell shapes, R1, R2, R3, R4, and then 5, 6 and 7 and 8. And then later on we're going to have the RSVP, and the admin groups are going to be red around the circumference, and then we're going to have green sort of crossing the cloud, and then between 1 and 2, 3 and 4, 5 and 6 and 7 and 8 we're going to be both red and green on the admin groups. But we'll come to that in the next few screens. Firstly, we want to turn on LDP. Now, of course, we need MPLS on. So we need the family MPLS on the interfaces, because, of course, it's going to be the actual encapsulation. We need that shim put on the packet. Now, we have a group already set up called IF families, set groups IF families, but we're going to be adding family MPLS to it. So it's interface GE004, unit star, and then family MPLS. And GE004 really does all of the WAN interfaces with the physical setup that we have for our equipment. And then, of course, we're going to be grabbing any aggregate Ethernets we may have and any unit on it. So that's the family MPLS. Then, of course, we need the interface to be in the MPLS protocol. We've got all of the interfaces in here, and then we've got disable on the interface we want taking out. And that's really quite a nice way to do that. Okay, now we come to the LDP. So here we have it. We're in router 1, turning on the LDP. Now, normally LDP would find its neighbours using multicast on 646 on UDP and then TCP 646. But we want to turn on the authentication key JNCIE. So because of that, we have to have the session set protocol LDP session router 2 authentication key JNCIE, and we're connecting here to router 2 router 4. We're going to track the IGP metric. The LDP has a metric of 1, which effectively becomes hop count. We really want the better metrics from either ISIS or OSPF, so track IGP metric. We've got explicit null, and that's going to change the label from penultimate hop popping, which is a label of 3, to label 0. So that will keep the labels on just a little bit longer across our small environment here. We also have LDP deaggregate on here because we really do want the label perfect. That's a historical thing. Originally, when MPLS was first envisaged, there really were as few labels as interfaces on the box, and the more aggregation you could have, the better. It kept the label size much smaller, and it created like a sea change in the size of the routing and switching tables in the routers. However, today there's plenty of label space, and we want to deaggregate that so that we have a label per FEC. Okay, the next thing is pretty important. It's an egress policy. Now, a little bit unusual. We're used to import and export policies, but here with LDP we can have egress policies. Now, LDP will only advertise on the Juniper router the loopback, and that's completely by design. So the loopback 0 in the routers is going to be advertised, but we'd like it to advertise a little bit further. So on router 1 and router 2, they've got an interface here that's shared to the Internet Exchange routers, and that interface can be seen here, 192.168.1.0. We would like that to be LDP advertised as well. And the reason for that is it's going to end up in the INET3 table. Of course, BGP is resolving in the INET3 table, and it's going to be able to resolve BGP routes from these Internet Exchange routers without having to do any sort of next hop addressing. And that's going to be really quite good. Okay, so we have an egress policy here. We turn it on, set protocol LDP, egress policy, LDP routes, and set policy options, policy statement, LDP routes, using it as an egress policy. Now, what we have to do here is this is exclusive. So as we add the this term here for the IX routers, it's going to remove the loopback. So we really do have to add it back in, click accept, and we're all good to go. Okay, the last thing we're going to look at is the ISIS interface. So a couple of things here. Firstly, we're turning on LDP synchronization. This is designed to prevent black holes because, of course, if the LDP was to drop halfway through a path, then and the ISIS wasn't looking for that, then the ISIS would effectively be sending traffic down a black hole. So LDP synchronization means that the ISIS is watching the LDP. If the LDP isn't there, then it advertises an incredibly high metric for that path so that it's not used. Have to be careful. Obviously, if you put LDP synchronization on an interface that isn't running LDP, then ISIS won't be advertising that metric properly. Of course, to do this, it needs to be point-to-point because we don't have the DIS involved, otherwise it gets incredibly confused. The protocol works only on point-to-point interfaces. Okay, then the final part of this is this family INET BFD liveness detection that's on. Now, In a couple of screens time, we're going to have some OAM liveliness detection, and that's going to be applied actually on the MPLS path. But this one is being applied on the ISIS itself. And the idea is it assists the ISIS for very short sub-second hellos. It's not as heavy as the ISIS hellos. It can be tuned down. And we have timers here of minimum interval 2000 multiplier of 3, which is basically 6 seconds.